All right, so this is going to be the video where we look over the Test 1 review for Math 1314. My intention with this is that you work through the review on your own and then you just kind of fast forward to the pieces that you need, not necessarily that you watch it all the way through. So if you haven't done the review yet, you need to pause the video, you need to stop, you need to go and actually work the review. So that way you actually get the most out of it as possible. Okay. But let's go ahead and jump into the review questions. So number 1, parts A and B asks you if these graphs are functions or not. Okay, so I'm going to kind of put the graphs up there because I don't want to draw them. Notice that both graphs are functions because they both pass the vertical line test. Okay, so for 1A, yes, it's a function. Passes vertical line test. Can't spell vertical apparently. And then it also asks you to use the graph to determine the domain and the range. Make sure you look back at your notes, but domain is the x values, so we go from left to right. Range are the y values, so we go from bottom to top. So the domain, if you look at that upside down V graph, I'm not going to show it, but you can look on your review. It looks like negative infinity to infinity, right? Because the arrows imply that that graph is going all the way to the left and then all the way to the right. As far as range goes, it starts at negative infinity, but then it comes to a peak at 1, including 1. So notice we use a bracket there. B is a function for the same reason. So remember, this is the graph that looks like it has holes in it, but it still passes the vertical line test. So if we look at the domain, again, left to right for domain, bottom to top for range. So if we look left to right, it looks like we go from negative infinity to an x value of negative 3, and we have an open circle. So we have to kind of pause there when we do the domain. And then we pick back up at negative 3, and then we eventually go to 2. Notice that it's important that we use parentheses for negative 3 and for 2 because all of those circles are open. Remember, parentheses means don't include the endpoint. A bracket like we had up here means do include the endpoint. Okay? And then the range is going to be bottom to top. So notice the range is, the lowest y value we have is negative 2. Even though there's an open circle, we do have some values at negative 2. In other words, we have some closed circles right here. And then notice the arrow just goes up forever. So we kind of don't care about the open circles as much here. Okay, we don't care about this one because there's a low point of negative 2 without this open circle. And then we kind of don't care about this open circle because this arrow implies that it just goes up and up and up forever. Okay, so make sure that you are prepared for any graph you might get on the test itself. Number 2. So you will have a problem, something like this, where you're given a function and then you're asked to find a couple of function values. And remember when we did this in class, it doesn't matter what the value is in the parentheses, you just plug that whole thing in. So this will be negative 1 to the 4th minus negative 1 cubed plus 3. This will be 2 to the 4th minus 2 cubed and then plus 3. Notice it's really important, especially with the negative numbers, that you put the negative number in parentheses, okay, if you're going to use your calculator. But here you'll get 1 because negative 1 to the 4th is positive 1. And then you'll do exponents first, so this will be a negative 1, and then that'll change it to a plus. So you'll get 5. You could enter this all in on your calculator too if you'd rather. On this one, 2 to the 4th is 16, minus 2 to the 3rd is 8. Notice I did exponents first and then I'll subtract and add. So I get 8 plus 3, which is 11. Okay. So remember, these are the y values. So f of whatever means what are the y values when x is, in this case, negative 1 and 2. All right, so for number 3, we change letters, but it's a similar problem. It's just that this time you're being asked to find g of x plus 5. So whatever's in the parentheses, that's what goes in for our variable. In this case, it's r. So notice, instead of r plus 5, I substituted in x plus 5, but then still plus 5, and then take the square root. So it's going to be the square root of x plus 10. So you add the like parts, which was the 5 plus 5, but the x and the 10 can't combine because they're not like terms. Okay, so number 4, I'm going to kind of project what the picture looks like. So for number 4, we're being asked to find function values, but we're not given an equation. We're only given a graph. Okay, so this is where it is vital that you remember what it is that f of 3 is asking you for. Okay, this is asking you for the y value when x is 3. Okay, and for that matter, f of negative 5 is again asking you for a y value, but it's switching up what the x value is. So it's asking you for the y value when x is negative 5. And then you're just looking at the graph to see that, right? So look at the graph at x equals 3 and tell me what the y value is there. Notice the y value is 0. And then look at that same graph at x equals negative 5. And notice that it's an open circle. Okay, so we call that undefined. But it's undefined because there's an open circle there. There's actually not a tangible value at x equals negative 5. Okay, so number 5 asks you to look at the graph from number 4 and just tell where the graph is increasing, decreasing, and constant. So I'm going to abbreviate here. Increasing, decreasing, constant, and I'm just going to go from left to right. So notice this graph has a lot of changes. Okay, this graph changes direction in a lot of different locations. So first, if you look from left to right, notice that it is increasing, and it is increasing from x equals negative 5 until x equals, looks like negative 3. Notice I'm not caring about the y values necessarily. I'm only listing the x values for increasing, decreasing, and constant. So if you need to write that down, you look at x values only, and we're always going to use parentheses. All right, so notice the next piece of the graph is constant, and it's constant from negative 3 to 0. And then the graph decreases for a bit from 0 to 2. And then it's constant for another bit. Remember, we use the union notation when we have more than one interval. So it's constant from 2 to 3. It increases from 3 to 4. And then last but not least, it decreases from 4 to 5. Okay, so this graph, notice, doesn't go on forever and ever, but if it did, we might have like from 4 to infinity if there was an arrow forever. So make sure that you know interval notation. It's going to be really, really, really important. You're going to need to know interval notation for domain, like we had in number 1, but you're also going to need it for number 5, the increasing, decreasing, and constant type problems. Okay, so let's look at number 6. Now, number 6 and 7, you have to show your work. Okay, so for even, odd, and neither, the way that you show that is you replace x with negative x and you simplify, and you see what you get compared to what you started with. Okay, so I would expect to see something like this where you worked it out and where you simplified it. Notice I changed it to an x squared plus 3 because a negative x times a negative x is a positive. So then you take this and you compare it back to the original. So because it's the same, then that means it's even. Okay, I expect to see some work. If you on a test were just to guess and give me your best guess out of the 3, you're not going to receive any credit for that. So that's why I'm trying to be clear on the test, and I'm bolding it and everything. Just make sure that you're showing your work. So the same kind of process for example 7, we're going to need to find g of negative x. So notice everywhere there was an x, I replaced it with a negative x. So make sure you do exponents first. So this would be 2 times a negative x cubed because it's an odd number of negatives. So that's going to be negative 2x cubed Okay, and then don't do the -6 for now, just worry about this, right? A negative x times itself 5 times is going to be a negative x to the 5th, and now you can go ahead and combine it with that, so you would get a positive x to the 5th, okay? And then again, you're going to compare, okay? And notice that it is not the same, right? But it's the negative version of the original, and if it's the negative version of the original, it's odd. But be on the lookout on the test for problems that may be where one sign changes and the other doesn't. That would be a neither situation because it is not the complete negative of the original. So just make sure you're careful on that. All right, so number 8 is a piecewise function. And then it asks you to find h of 3 and h of -2. So it's very close to number 2 on the same review. It's just that you have to make a decision about which equation you should be using based on the x value. Okay, so notice that 3 is greater than or equal to 0, right? So we need to use equation 2. So you shouldn't be using both equations. That would actually make it no longer a function. So you would do 7 times 3 plus 3. Make sure you multiply first, but 21 plus 3 is 24. Okay. And then for this one, notice that our x value is -2. So when you go here and try to decide which pattern is applicable here, notice that -2 is less than 0. So we need to use equation 1. Okay, so that would be 6 times -2 minus 1, so -12 take away 1 would be -13. Okay, by the way, these are both still the y values when x is whatever. Okay, it's just that you have to decide which equation you need to use at the beginning. All right, so for number 9 through 12, really, you're writing equations of lines, so make sure, off to the side, make sure you know things like y equals mx plus b, y minus y1 equals m times x minus x1, and that the slope formula is y2 minus y1 over x2 minus x1. Okay, you're going to need to know those formulas, know what they're called, and know when it's appropriate to use which one. Okay, so for number 9, notice that you have a slope and you have a point. Okay, so that is classic point slope. So we're going to use this equation and plug in what we know. So it's going to be y minus the y value, that's the y value, right, equals m times x minus the x value. Okay, so be careful about our signs here. So we get y plus 3 equals -3 times x plus 2. But then we're going to try to write this as a y equals equation. Okay, you're probably going to be asked to do that on the test. So it's y plus 3 equals -3x minus 6. And then subtract 3 from both sides. So it looks like y equals -3x minus 9. Okay, then if you were asked to graph this line, you know that the slope is -3 and that the y-intercept is -9. Okay, so for number 10, same thing, right? You know that you have points -2, -4, and 1, -1. Okay, so it's very similar to number 9, it's just that you don't have the right information quite yet. In other words, you need to know what the slope is. Okay, so you need to figure that out. So it's y2 minus y1, notice the double negative there, over x2 minus x1. So that's -1 plus 4 on top, 1 plus 2 on bottom. So you end up getting 3 over 3, which is just 1. And now I'm going to use that to use the y minus y1 formula, the slope-intercept formula. So you don't, it doesn't matter which of these 2 points you decide to use. I'm going to choose this one just because the numbers happen to be smaller, but you would get the same result either way. So y minus the y value equals the slope we just found times x minus the x value, because remember this is x, that's y, right? So I end up getting y plus 1 equals x minus 1, right? Because 1 times something is just itself. And then last but not least, I'll subtract 1 from both sides. So it looks like I get y equals x minus 2. Okay, remember the understood slope in front of something like this would be 1, right? So it's up 1 over 1 is the slope, and the y-intercept is -2. Okay, so number 11 gives you actually the same information, just in a roundabout way. Okay, and we know it's perpendicular to x minus 2y minus 3 equals 0. So we did one like this in class. So we need to remember what it means for lines to be perpendicular to each other. It means that their slopes are negative reciprocals. But honestly, before I even worry about that, I need to make this equation look like y equals so that I can pull the slope from it. Okay, so notice I moved the x and the 3 over, right? And then I still want to make sure that I have y equals, so I'm going to divide by -2. Notice I multiplied or divided everything by -2. So I get 1/2 x minus 3/2. It's a 1 because the understood number is a 1, and then it's a positive because a negative over a negative is a positive. Okay, so notice the slope here is 1/2. Okay, but I want the slope that's perpendicular to it, right? So I want the perpendicular slope, and that's what we're going to use, right? So the perpendicular slope would be -2 over 1. Okay, so now I've got a slope and a point, and now I'm going to do my y minus y1 thing. So it's y minus the y value, almost forgot a sign there, equals the slope times x minus the x value. So we get y plus 7 over here. We're going to go ahead and distribute the -2. So we're going to get -2x plus 8. And then last but not least, subtract 7 from both sides. So y equals -2x plus 1. Okay, so notice on these last 3 problems, they're all very similar. We get to the point where we want to use this y minus y1 formula. It's just that you kind of had to go and work a little harder to get the slope in 10 and 11 than you did in number 9, where I just gave you the slope. All right, so number 12 is not really a problem where you have to show work. It's just a kind of do you know it or do you not know it kind of question. Because vertical line equations always look like x equals a number, and so it's going to look like x equals something. And then horizontal line equations always look like y equals a number. Okay, so notice that the vertical axis is the y's, the horizontal axis is the x, so you kind of flip-flop, right? The vertical line is described by x, the horizontal line is described by y, and then you're just pulling the x or y from that point on your review. So notice the x value is 2, so the vertical line through that point would be x equals 2, and then the horizontal line through that point would be y equals 4. Okay, so notice we need the x equals and the y equals. It's not okay for you to just say the number. It needs to look like an equation of a line. Okay, so starting with 13 and 14, that is the section where we talked about transformations of graphs. So just remember that there are 6 total different types of transformations. You're going to need to know them, because any of them are fair game on the test. Okay, so just make sure you know the 6 transformations, and you need to know the basic common graphs. I handed out a handout for that. Okay, so if you're online, you should be able to look in D2L and find that handout. Okay, so for number 13, the first thing is you're going to need to be able to know what the original looks like. So before I start, I'm going to use my red pen. In other words, you need to know what the parent function looks like. Well, a cubic function looks like this when you graph it. And then you just need to know what changes are being made. Okay, so notice this is a shift to the right 4. Remember, horizontal shifts work in the opposite direction of what you might have thought. And then this is going to be up 3. Okay, so we are going to go up 3 and to the right 4. And then we're still going to have our curve. Okay, so I'm going to call this the final graph after the changes were made. Okay, but just know that, remember, this is only 2 of the 6 changes. There are 6 total ones. There's 2 types of reflections also, and then there's also vertical and horizontal stretching and shrinking. So you need to make sure you look back at all of those. All right, so for 14, you are asked to describe what's going to happen with this graph. Now, if you tend to not be good at the graphing portion, remember that you'll get some credit just for describing what changes you think are going to happen, and in what order. Okay, so on the review key, make sure that you look at the steps for graphing multiple transformations. Okay, so it looks like this, but I have listed what goes in what order. Okay, but remember, the main thing is work from the inside out. Okay, so the first thing is, let's just label what's happening. This is going to be up 1, right? If you add a number to the end of a function or subtract, it's a up or down shift. And then this 3 here is going to vertically stretch it by a factor of 3. But then this negative sign is its own thing, okay? And negative to the front is a reflection over the x-axis. Okay, and remember, we work from kind of the inside out. So this is the first thing, this is the second thing, and this is the third thing. Okay, vertical shifts are always the very last. So you could literally do something like this on your test where you just kind of say what happens and then number them one at a time. So we would literally do that. So I'm going to kind of show you the key because I don't really want to draw the original, and I'll just kind of show you how I did what I did. So here's the original, right? So if we look at the original, I just went a point at a time, and I started with this end point here, and I said, okay, I need to vertically stretch this by a factor of 3. Notice it's on the y-axis, or x-axis rather, nothing happens to it. Then reflect over the x-axis, again, nothing happens to it, and then finally shift up 1. Okay, so notice that's where I put the new point there. Same thing here. The reflecting and the vertical stretch are only going to keep it where it is, right? So notice all 3 of these points that were crossing at 0 are now crossing at 1. But then let's talk about the peak of the curve and the low point over here. So notice here's the peak at 1, right? So since the peak is currently at 1, it's going to triple because it's getting 3 times taller. And then it's going to flip over the x-axis, so notice we're here, and then it's going to shift up 1. Okay, so I'm literally doing all 3 changes kind of slowly as we go, right? So same thing here. We're going to vertically stretch it by 3. We're going to flip it over. We're going to end up right here, but then we're going to shift it up to here. Okay, so make sure you practice some of those. Again, 6 transformations are possible on the test. Okay, so I probably won't do one problem with all 6 of them, but you do need to know all 6 of them because you don't know which ones I'm going to ask about. All right, so for 15 and 16, remember our domain rules are no 0 in the denominator and only positive numbers under the square root. Okay, that's our rules for domain for 15 and 16. So if you look at 15, I think we can probably eyeball and know, okay, for the first fraction, x can't be 2. And for the second fraction, x can't be -8. Okay, but I want you to list this in interval notation. So here's where I had you draw a picture, and I told you that the picture was optional. But I do think the picture helps you get there, right? I want to kick these guys out, but I want to include everything else. So while the picture is optional, this interval notation is not. So it's -∞ to -8, parentheses, right? We want to not include it. And then -8 to 2, not including either one. And then 2 to infinity. Okay, so if you can get there without the picture, that's cool, but it really just took us like a few seconds to draw the picture. So I don't think it's something that you can't do. All right, so on number 16, make sure you go back and look at these in your notes. You know, the review is just a quick, you know, here's a problem or 2 of each type, and you do need to go back and practice and look at the problems that you struggle with more than just maybe 1 or 2 examples. So kind of keep that in mind. So remember, we only want positives. So we want x minus 4 to be greater than or equal to 0. Okay, this part is always what gives you positives. Okay, like you will always say whatever's under the square root is greater than or equal to 0. Okay, and then you just solve for x. Notice this one's not too bad because I don't really have any negatives or anything. So I didn't end up having to do anything like that, but remember, if this were a negative, you would need to flip the greater than to a less than. Okay, but as it stands, I don't need to do that. So I want 4 included, and I want everything bigger than 4. So picture's optional, but this interval notation is required. So I want everything from 4 up to infinity. Okay, so just remember, we did one in class where we had a negative x here, where maybe it was like 4 minus x or something. So you need to make sure you know how to do that. But if you divide or multiply by a negative number, you flip the greater than to a less than, or vice versa. You flip that inequality sign. Okay, so for 17, we have f of x equals 7x plus 1, and we have g of x equals x squared minus 3. Okay, so make sure you know that this little open circle operator means composition of functions. So when you see f composition g, that is not a multiplication. Okay, it means f of g of x. So remember, we always start on the inside. So we don't worry about f right now. We just insert in what g of x is, and notice g of x is x squared minus 3. But now we do worry about f. Now that we plugged in the inside, now we're going to stick that into the outside function. So instead of 7x plus 1, we're going to do 7, put this in parentheses in there for x plus 1. Okay, so just like before, f of something just means plug it in. That's all it means. So notice this is going to be 7x squared minus 21 plus 1, and so we get 7x squared minus 20. Okay, notice that the 7 doesn't distribute to the 1, right? The 7 only distributes to the parentheses. So I wanted to show these side by side to remind you of something. Okay, f of g and g of f in general are not the same thing. Okay, only when they're very special functions called inverses, which is actually what we talk about next, only when they're inverses do we end up getting the same for both of them. So again, you always start on the inside. So this time we don't worry about g, we just replace f of x with what it is, which is 7x plus 1. But then this means go plug that in, right? So we get 7x plus 1 parentheses squared minus 3. Okay? Do not, we talked about this when we first learned it, do not distribute the squared. You're not allowed to do that when you're adding and subtracting. You have to instead think about it as something times itself, and then you have to FOIL it. So notice if you expand it out like I just did, then I think it's more obvious that you need to FOIL it. So 7x times 7x is 49x squared. Outside would be 7x times 1, that's just 7x. Inside would be 1 times 7x, which is 7x. 1 times 1 is 1, minus 3, and then combine any like terms. Okay, so always give simplified answers on tests. That's how you're going to get full credit. And then lastly, let's find f of g of negative 3. Okay, now one thing you could do, if you already know f of g, you can just go plug it in here. But I'm going to pretend like we don't know it, because maybe I might give you one on the test where you don't have to find the equation. And in this case, you're still going to start here. You're still going to start on the inside. You always do that with composition of functions. So first, I'm just going to find what g of negative 3 is. So notice that would be negative 3 squared minus 3. Okay, be careful of your signs. Negative 3 times itself is positive 9, which gives me 6. But then that's not my answer. That's just what plugs in here, right? So g of negative 3 was 6. So now I'm just finding f of 6. And now, of course, that just means plug 6 into this equation, right? So that would be 7 times 2 plus 1, or 15. Okay. Notice that if you wanted to, you could have just plugged negative 3 in here, and you would have gotten the same answer. Okay. actually, hang on. So what did I do off here? Let me make sure what I got going on here. So g of -3 was 6. Oh, I don't know why I did that. I plugged in a 2 when I should have been plugging in a 6. Sorry about that. Not even sure where I got a 2 from. So if you do 4 times 6 plus 1 like we should be doing, then you get 43, which is the correct answer that's on your key. So sorry about that. So don't make goofy mistakes like that. Not really even sure where I pulled that out from, but it happens. Okay, so for number 18, find the inverse of f of x equals 3x minus 1, and then show it's the inverse using composition of functions. So first let's find the inverse. Okay, so first you would at least maybe picture what the graph looks like. It's a line, okay? So it passes the horizontal line test. Remember, things that don't pass the horizontal line test, we don't even worry about trying to find the inverse because it doesn't have one, okay? So we have y equals 7x plus 1. So the inverse is going to be x equals 7y plus 1. Okay, and then you have to make this equation look like y equals. So we subtract 1 on both sides. We get x minus 1 equals 7y. Divide by 7, and we get y equals x minus 1 over 7. You also could call that x over 7 minus 1/7 if you wanted to. Okay, so that's the answer, but then you're also supposed to show that it's the inverse using composition of functions. In other words, remember, it hasn't been that long ago that we talked about composition of functions, but f of g of x and g of f of x are both supposed to equal each other and supposed to equal x for inverses. So let's show that real quick. So we need f of g of x. We're going to do that here, and then we also need g of f of x. And we need to just verify that we actually get x in both cases. Okay, so we always start on the inside. So here we're going to start with g. And here we're going to start with f. Okay. By the way, we're calling this our g, our answer right here. Okay, so f, it would be f of the answer we got there, x minus 1 over 7. So that means plug it in, right? So I'm going to get 7 times x minus 1 over 7, and then plus 1. So notice, in this case, the 7's would go away. Okay, we would get x minus 1 plus 1 once we cancel the 7's, right? Because remember, this is like 7 over 1, if you're wondering why I was able to cancel that out. So 1's on top and 1's on bottom. And then this goes away, leaving x. So I'm going to put a check mark here. Okay, I needed this, but that's only half of the equation. I actually need to make sure it works over here too. So here I'm going to find g of 7x plus 1. So I start on the inside. So that means go replace x with 7x plus 1. So notice I'm using g, right? We're going to call this g of x just to make sure we're clear on that. And then let's see what happens, right? So notice this time the 1's go away first, leaving 7x over 7, and then the 7's go away. Leaving only x, right, which is what we wanted to happen. So here is the conclusion. Since they are both equal to x, then f and g are in fact inverses. So you likely will have a question like that on the test that maybe even gives you the answer, like tells you, hey, these two are inverses. Now show they are by using f of g and g of f. Okay, so let's go ahead and look at this one. Now I told you when we first learned this that this would likely be on the test, and so I'm telling you again, this is probably a type of question you should expect to see on the test. So the first thing is this graph is going to be a rational graph. You could graph it if you want to, but it does pass the horizontal line test if you wanted to graph it. all that tells us is we can proceed. All right, so we start off with saying that, hey, the new inverse is going to be x equals 2y plus 2 over y minus 3. Okay, notice we always swap x and y. That's how we always first look at inverses. But then we're going to consider that as over 1, and we are going to cross multiply. Okay, so what you get when you cross multiply is x times y minus 3 equals 1 times 2y plus 2. So we get xy minus 3x on the left, and we get 2y plus 2 on the right. Okay, so we're trying to solve for y, and what I want you to notice is there are two y's. Okay, now you can't solve for one of them. You have to actually combine them together. So what I'm going to do is I'm going to move anything with a y together, and then I'm going to move anything without a y away. Okay, so notice that would send those away, right? So I'm going to get xy minus 2y equals 3x plus 2, or 2 plus 3x, it doesn't make a difference. And then we're actually almost there. Then hopefully we see that, hey, there's a y in both of these, so I'm going to factor it out. If you divide a y from the first term, you get x. If you divide a y from the second term, you get 2. And then last but not least, if I want y all alone, y is being multiplied by something that I wish wasn't there, so the opposite of multiplication is just division. Whatever I do to one side, I have to do to the other. So I end up, notice that's going to be helpful because it's going to get rid of it there, but I end up with 3x plus 2 over x minus 2. Okay, so this is the inverse equation. Remember, we also could write it as this format. So when you see this, it also means inverse. Okay, so it's not an exponent. It's not to the -1 power or anything goofy like that. So definitely make sure that you look at that. And then the last few problems are the very last section of the unit. Let's look at A. So the first thing is we're going to fill in what the three marks are. So it's probably helpful if we notice what the pattern is first. Okay, so notice, what's the pattern to get from one number to the next? Like, notice we're not adding the same number every time, right? So the pattern's not addition. The pattern is actually that we're multiplying by 2. And once we know that, it's pretty easy to fill in the blanks, right? So this would be 64, right? Doubled. This would be 128. This would be 256. Okay, so anytime you have a multiply pattern, it is geometric. And remember, the nth term formula for that looks like this. It's going to be a sub 1 times r to the n minus 1. So it's going to look like first term, that's what a sub 1 means, times the r you're multiplying by to the n minus 1 power. Okay. So remember, we talked about this in class, but you never, ever, ever multiply the 4 times the 2 here because order of operations says I should do exponents first. Okay, so this is the type of sequence that it is, so that would go in that blank where it says blank sequence. All right, so let's look at the next pattern. I think these patterns are pretty easy to pick out. In other words, they're not hard patterns to, eyeball. Notice that this time we are adding 7. So that is a classic arithmetic sequence. So that goes in the blank where it says blank type of sequence. And then we're just adding 7. So the next one will be 35, 42, 49. So remember, the formula for the term here is a sub 1 plus, I will be giving you these formulas. So it's a sub 1 plus, just lost my train of thought, n minus 1 times d. Okay. So let's plug that in. So a sub 1 will be first term plus n minus 1 times d. In this case, it's 7. So I do want you to work this out. So make sure you actually simplify this. So this would be a sub n equals 7 plus 7n minus 7 if you distribute that 7, or just a sub n equals 7n. Okay, remember the helpfulness of these a sub n formulas is I could skip to the 50th term if I wanted to without having to go in order like I did here, right? It'd be very tedious to write out 50 blanks, but I'm able to go to the 50th term or whatever term I want to go to using these a sub n formulas. And then the last two questions on the review are just applications of those sequences. First, you need to figure out which type of sequence it is. Okay, number 21 says you graduate and you're offered a yearly salary of $40,000 with an expected yearly pay raise of $900. Okay, so you start with 40 and then you raise 900. So let's just list out a couple of your pays. Year 1, you're going to get 40,000. Year 2, you're going to get 40,900. Year 3, you're going to get 41,800. And then so on and so forth, right? So hopefully you can see the pattern is that we're adding 900 every time. 700, I mean. Nope, 900. Okay, so because it's an addition pattern, that means it's arithmetic. So the first thing you are supposed to do is come up with a formula. Well, we just practiced that in number 20. The formula for arithmetic sequences looks like this. And so I just need to fill it in, right? My first year salary, which is a sub 1, is 40,000 plus n minus 1 times a 900 value for the d. And then you'll just use distributive property and clean it up. So it'll be a sub n equals 40,000 plus 900n minus 900. So we get a sub n equals 40,000 take away 900 is 39,100. And then plus 900n. Okay, notice that would work for any of these years, right? If you plug in 1 here, the first year, right, you get 39,100 plus 900, which is 40,000. That works, right? If you plug in 2, you're going to get this number. If you plug in 3, you're going to get this number. Okay, so it works, but then it asks you to jump to the 10th year. So without having to write them all out, we can do that, right? We just need to plug that in our calculator. And if you do plug that in your calculator, you'll get 48,100. Okay, so make sure when it's money, you indicate that with a $sign. Okay, but 22 is a pay problem where you get a percentage raise, and that is different, okay? A percent raise is always geometric, always. Okay, and because it's a raise, and we talked about this in class, but because it's a raise, R is always going to be basically 1 plus the percentage. Okay, so R is actually going to be 1.02. Okay, think of it like 102%. So 100% of your previous salary would mean you kept it the same, and then we got an additional 2%. Okay, so it's basically, this means original 100% plus the extra 2%. Okay, so when it's geometric, we use a sub n equals a sub 1 times r to the n minus 1. So to find the general formula, we would take the first year's salary, which was 21,000, and we are going to multiply by that r of 1.02 to the n minus 1 power. And we don't multiply the 21,000 and the 1.02 because we have to deal with exponents first. Okay, and then it asks what's this person's salary in the 30th year. So no way we would want to actually enter all those in, right? But if you work that out, you end up getting $37,292.74. Okay, so probably the biggest thing missed on test 1 is this right here. Okay, make sure that you understand that a percentage increase raise is actually 1 point and then whatever the percentage is. Okay, so we're actually figuring 102%, not just 2%. Because by the way, if you made R 2%, that would mean you're paying the person 2% of what they made the year before, and that's not what's happening, right? I think we would all quit at that point, but you're actually paying them 102% what they made the year before. Okay. So remember, just like any math test, okay, the way you study for a math test is to practice problems. Okay, so this review is supposed to be like a starting point for you. So you look at the review and you ask yourself, which questions am I having the most difficulty with? And you look up questions like that and you practice more of those. Okay.